Hello students, welcome to our next chapter, which is sequence and series. So in this video, we will learn about arithmetic progressions and geometric progressions. Arithmetic progressions we had already learned in class 10, but still we would like to start with AP only. Arithmetic progressions. Even before AP, you should know what is a progression. A progression like a progression or a sequence, right? A sequence is a set of numbers, like when numbers are written by putting commas in between, and they follow a particular pattern, right? Like if I give you an is equal to 3n minus 1. Here, this small n denotes the number of the term. You must have learned this in class 10 that an is the general term of any sequence, number of the term. And since we can have these numbers can vary from 1 to any other number, infinity. So that means this small n belongs to natural numbers, right? So if we have, first of all, we should know what kind of sequence or what kind of progression this sequence is, the set of numbers is. What I do is I put a1 here, put the value of n is equal to 1, n is 1, do the same on right hand side. So a1 comes out to be 3 minus 1, that is 2. What is a2? a2 is 3 into 2 minus 1. 6 minus 1 is 5. a3. a3 is 3 times 3 minus 1. 9 minus 1 is 8. And I will just like to add one more. 3 times 4 minus 1. 12 minus 1 is 11. So now see, sequence is given as, or you can write this as 2, 5, 2, 5, 8, 11, and so on. This is the format of a sequence. Like we write numbers by putting commas between them, and a sequence can be of so many types. But we are right now restricted to arithmetic sequence and geometric sequence. Now, how to check whether a sequence is an arithmetic sequence or not? For arithmetic sequence, what you should have is check the difference between the consecutive terms of a sequence. Like this, what is the difference between 5 and 2? It is 3. Difference between 8 and 5, it is 3. 11 and 8, it is 3. So when we have common difference between any two consecutive terms, same throughout the sequence, it is called arithmetic progression. Or you can call this is NAP, right? That means the difference between two consecutive terms is same throughout. Now this is called the first term, A1. This is called the common difference, D. And if A1 and D are known to us, we can find any term, like we can find random term, like 25th term, 200th term of this sequence. What number will appear in 201 place? What is 201th term? So that means we need not keep on adding 3 to the existing term to get that number. We can simply use this formula. You must have learned this in class 10. An is A1 plus n minus 1 times D. So if I want 25th term, I will simply put n as 25. A1 here is 2. N is 25 minus 1 times D is 3. This is 2 plus 24 times 3. So A25 becomes 2 plus 72. That is 74. Right? So this is the nth term. This is the formula for nth term of an AP. Now the basic characteristics of AP I have told you. Let us move to GP, geometric progression. So in class 11, we have geometric progressions in our syllabus. And after that, we will learn how to find nth term of a GP, sum of GP, sum to infinite terms of a GP, And then we have AM and GM, relation between arithmetic means and geometric means, right? So let us start with geometric progressions first. Now you have learned an AP is a sequence in which if we add a number to the existing number, we get the next term. You add 3 to 2, you get 5. You add 3 to 5, you get 8. Keep on adding a constant number to the previous term, you will get the next term. Now what happens to GP? If I have see what is the relation? You should be able to see, you must be getting these questions in common aptitude exams also. You should find the relationship between the existing terms. So 3, 6, 12. You can see the numbers are getting doubled. Twice of 3 is 6. Twice of 6 is 12. No, see. Twice of 12 is 24 and twice of 24 is. So the common behavior throughout the terms of this sequence is what? The number at a previous place is getting multiplied by a constant number throughout the sequence to get the next number. So when this is the case, like earlier we had sum, we were adding something to get the next term. Here we are multiplying, right? We are multiplying 2 by the existing number to get the next term of the sequence. Such a sequence is called geometric progression. Let this be A1. 3 is A1. A2 is what? 3 times 2. That means this is A1. This is called common ratio. R is common ratio. Here we, in AP we had common difference. Here we have common ratio. This is R. So what is A3? A3 is 3 times 2 times 2. That is 12. This is A1, A2, A3. A3 is 12. You can write it like this. Now what is this? This is A1 into R into R. So A1 is A1. A2 is A1 times R. Check the pattern here. A3 is A1 times R square. A4 is what? A4 is 24. 3 times 2 times 2 times 2. 3 multiplied by 2 multiplied by 2 multiplied by 2. So that means you can check this is 24. So A4 is what? A1 R 3 times R is getting multiplied. Check the pattern here. A1, when the second term R is getting multiplied once. When we have third term, R is getting multiplied twice. In fourth term, R is occurring for power 3. So if you check the pattern, we can find nth term of a geometric sequence by this formula. Once you have to take A1 and see, when it is 2, power of R is 1. When number of term is 3, power of R is 2. When it is 4, power of R is 2. So we can say An will become A1 R raised to the power n minus 1. So this is the formula for nth term of a sequence, geometric progression. Right? Nth term of a geometric sequence. Right? So let us take some example here. Okay, here we have to, let's see, start with the question 2, 8, 32. Which term of this sequence up to n terms? Which terms of this sequence up to n terms is 1, 3, 1, 0, 7, 2. 1, 3, 1, 0, 7, 2. Right? So start this way. This is your A1. A1 is your first term. You can check 2 and 8. We multiply 4. It is given that this is a GP. So common ratio here is 4. First term is 2. You can see here 8 times 4 is 32. Now we have A1 and R. We have to find at which number, at which place this term will come into this sequence. Like it is 25th term or 12th term or 8th term. You have to find the number of term for this value, right? So an is what? An is a1 times r to the power n minus 1. You put this value here, 131072. What is a1? It is 2. R is 4. 4 raised to the power n minus 1. Right? I have just put the values in the given formula for nth term. Now, nth value of nth term is given. We have to find n, at which number this particular value is existing in this GP. So now divide 131072 by 2. This is 2 times 6, 2 5s are 10, 2 5s are 10, 2 3s are 6, 2 6 are 12. Right? That means you have to check for what value of 4. This has to be some power of 4. Now you need to do the prime factorization of this number. 6 5 5 3 6. Right? 2 2 6 are 12, 2 5s are 10, 2 5s are 10, 2 3s are 6, 2 2s are 4, 2 7s are 14, 2 6s are 12, 2 8s are 16, 2 1s are 2 6s are 12, 2 3s are 6, 2 8s are 16, 4, 2 1s are 2, 2 9s are 2, 2 4s are 2 0s are 2 9s are 18, 2 6 are 0. See, you know 64 is 4 cube. I can stop here. This is like 4 times 4 times 4, right? 4 cube is 64. Now, this is 4, this is 4, this is 4, 4 and 4. How many 4s are there? 4, 4, 4, 4. And we have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Right? 4 raised to the power 8 is equal to 4 raised to the power n minus 1. Right? Now I have solved this. Now taking prime factorization of this number, here we have base 4. So instead of 2, I took 4 as the base just to equate this. Now equating the bases of these two equations, we have 8 is equal to n minus 1. 8 plus 1 is equal to n. So n becomes 9. Right? That means this will be 9th term of this sequence. Right? So this was the basic about how to find nth term or to find n for the given value of any term. Now I am explaining you what is the formula for sum of n terms of n GP. Sn for a geometric progression. Sum of n terms. So I just told you like A1, A2, A3 is a GP, right? So if we have to find Sn, the formula for Sn here is A1 times. Now, before getting to the formula, you must have seen that some sequences are increasing in order. Like you can see, I took 3, 6, 3, 6, 12, 24, and so on. Here R is 2. Common ratio is 2. Now R is greater than 1, right? This is an increasing sequence. So when we have r greater than 1, then we write the formula as A1 Rn minus 1 upon R minus 1. Otherwise, see, answer remains same. Even if you use either of the formula, the other one is just writing it in the reverse order. A1 times 1 minus Rn upon R minus 1. Now, why do we do this? 1 minus R. Why do we do this? When R is less than 1, so ideally we are supposed to subtract the fraction from 1. Even if it comes out to be negative in the numerator, it will be negative in denominator. So answer will not be affected. But ideally, we should use the right formula according to the value of R, right? So if we have some decreasing sequence, let me give you one example. Like 1, 2 by 3, 4 by 9, 4 by 9, and so on. If this is a decreasing sequence, see 1 is greater and this fraction is getting smaller. In this case, your R is what? R is A2. How do we find R here? This is a fraction. A2 divided by A1. What is A2? 2 by 3 divided by 1. So R is 2 by 3. This divided by 4 by 9 divided by 2 by 3 is 2 by 3 itself. Now this R is less than 1. In such kind of situations, we use this formula for Sn. Right? Sn is A1 1 minus Rn upon 1 minus R. So let us do two questions for each of these kinds. Like if we have a sequence given as 2, 4, 6, 8. Sorry, this is an AP. 2, 4, 8. This is times 2. And you have to find sum of first 8 terms. S of 8. So formula is here R is what? A1 is 2 and R is 2. So Sn formula you will be using is A1 Rn minus 1 upon R minus 1. So S8 becomes A1 is 2. R is 2. 2 to the power 8 minus 1 upon 2 minus 1. This is 2 times 2 to the power 8 is 64 times 4. 4 is 16. 256 minus 1 upon 2 minus 1 is 1. So this is 2 times 255. Right? 510. Right? This is the sum of first 8 terms of this sequence, which is an increasing sequence. Right? Now let us take the previous example that we were doing. Like if we have 1, 2 by 3, 4 by 9, and so on. Find the sum of first, let's say 8 terms only, right? S8 you have to find. What is A1 here? 1. R is 2 by 3. What will be S8? It will be A1. Use this formula. I'm writing formula here. San is A1 1 minus R to the power n upon 1 minus R. Why we are using this formula? Because R is less than 1. So A1 is 1. 1 minus R is 2 by 3 raised to the power 8 upon 1 minus 2 by 3. Now you can solve this as 1 minus 2 to the power 8. We had just done 256. And 3 to the power 8 we have to solve. This is 81 times 81. 6561. 561 divided by, this is 1 minus 2 by 3, that is 1 by 3. Now you can solve this. Six five six one minus 256. 6305. 6305 divided by 6561 into 3 goes over there, right? Now we can reduce this. 6 times 2, 3 ones are 3, 3 eights are 24, 7, right? 6305 divided by 2187 is the sum of 8 terms of this GP, right? So these were only formula. We cannot do more tough kind of questions in this one. The basics about arithmetic mean and geometric mean, right? Now, what is arithmetic mean? Arithmetic mean, right? Arithmetic mean is a very common term you have been hearing since class 5 or 6. Arithmetic mean is nothing. When we have few values, it is also called mean or average. So when we have few values, we simply take the sum of those observations divided by the number of observations. That is called arithmetic mean. Now, that is the same thing. So when we are talking about arithmetic mean, let us start with two numbers. If we have A and B, so what would be the arithmetic mean? Now we will try to learn the basic concept of how do we find it and what is the usage of that thing. Arithmetic mean is nothing but sum of these two values divided by 2. That means taking the midpoint of these two. This is the same thing that we do in statistics when we take the midpoint. Basically, it is a measure of central tendency. We are finding the mid value of a data. And if we have only two numbers, we simply take the sum of these two and divide by 2. So the number that we get is, the concept is, here we have AM in the middle of these two numbers, right? Now, what is the usage of this AM in case of arithmetic progressions? Let this number be C. If we have A, C, B, try to learn this, because how do we get this formula and why do we use it? All these things make sense when you know how do we get this thing. When we put the C here, this is the mid value of A and B. Mid value means the difference between these two numbers will be same as the difference between these two numbers. That means these three numbers right now are forming an arithmetic progression, right? Since this number, the gap between these two numbers is the gap between these two numbers in a case of addition. So didn't we learn this in AP? If we have the difference between these two numbers same as the difference between those numbers, that means these three numbers are in an arithmetic progression, right? So how can we write this? C minus A is equal to B minus C, right? Now solve this, take C to this side and this becomes B plus A. So twice of C is B plus A. This is a result that you can directly use when it is given in the question that three numbers are in AP. So when three numbers are in AP, that means this is the middle value. So twice of the middle value will be equal to the sum of these extreme values, right? This is a relationship between these three numbers where C is the arithmetic mean, right? So this was the case when we had only two numbers, right? If we have like two numbers A and B, and we have to insert, let's say, now we don't only require one arithmetic mean, we have to insert, let's say, three numbers between these two numbers so that the resulting sequence is an arithmetic progression, right? Or we can say, let me take some examples so that I can go around with that. I'm starting with this A and B, and we have to insert, let's say, wait, 5 numbers or Let us take 2 and 32, right? I just need a break, Nausea. Just give me a minute.
Yes, ma'am, sure.
I'm so sorry.
Yeah,
Extremely
yeah, sure,
sorry.
no
You have
issue.
to cut this thing.
Yes, yes.
Because if I start with the wrong example, that would not be.
Okay, ma'am.
That is a problem. Actually, so many things have been removed from NCRT and CBSE. They are
Okay.
not there in NCRT and CBSE, but their context is there. So how to explain it and how to use questions, that is a bit difficult.
Okay, okay.
Now, GP is there, AM is not there.
Okay. Now nth term and sum of series you are starting, right, ma'am?
Sorry?
Nth term and sum of series.
Sum of series was there. Till last, that was there.
Okay.
I'm just looking one question. I'm not able to find it here. What the topic now? It must be having. Fine.
Okay, ma'am.
You can just start from the last slide after the last slide.
Okay.
Like editing work has been increased a little bit.
Okay.
Okay. Let us start with how about inserting, if we have to insert more than one number between two numbers. They are all called arithmetic means. Like if we have A and B, A and B, there are two numbers. And let's say we have to insert three numbers between them. Now try to understand the concept. Later on, you can remember the formula, right? If A and B are there and we have to insert three numbers, right? See, this interval is now broken down into one. Three numbers are there. This is 1, 2, 3. This interval between B and A has been broken down into four different parts, right? The gap between A and B has been broken down into one. These are the intervals 1, 2, 3, and 4. That means this gap is basically the common difference now between these five consecutive terms 1, 2, 3, 4, 5. We have to insert three numbers between these two values so that they form an arithmetic progression. That means the gap between these two numbers is now what? Is D, right? So first we have to find D. If this A and B are given, we need to find what is the value of the common difference at which we can place these three numbers. How to find this? D, the formula for D is B minus A upon N plus 1. See, you can learn formula directly also, but try to understand it. This gap between A and B, that means B minus A. B minus A is the total interval between A and B. This has to be broken down into, if you have to insert three numbers, this is getting divided into four intervals. If the numbers are 4, it will be 5. Numbers are 5, it will be 6. So as many numbers we are inserting into this gap between A and B, the whole interval, this b minus a, is getting divided into n plus 1 intervals. I hope this is clear. Now this is the value of d. Once you get this is the value of d. Once you get this value, this is your am. Let me erase these things from here. This is your am, am1, am2, am3. These are three arithmetic means that we have to insert. Now how you will get this value? This value, you already know a and b. This will be given to you. This value you can get am1. You will get this by adding d to a. Add d here, you will get this first value, right? So a plus d. a1 plus d is your am1. These formula are given in the books, but try to understand it so that if you get stuck in a difficult question, you should know what is the concept behind this. Now, how you will get this? am2, this is a, add d to it, add once more. That means a2, a1 plus 2d. And finally, am3 is a1 plus 3d. Right? So don't confuse this for like here it is 1 and d is 1. That AP is a different thing. Here we are putting AMs and it is starting with the given number. So it is A1 plus D and this. Let us do one question so you will get this clearly. Insert three arithmetic means between 3 and 19. 3 and 19, right? So this is your A, this is your B. A and B. What will be the value of D here? We have to insert three numbers, right? So the value of D is B minus A, 19 minus 3. This whole interval has to be divided into 1, 2, 3, 4. 19 minus 3 is 16, divided by 4 is 4. So the common difference here comes out to be 4. The value of arithmetic mean 1, AM2 and AM3. What is AM1? AM1 is A1 plus D. 3, A is 3, D is 4. This would be 7. AM2 is A1 plus 2D. 3 plus 2 into 4. 11. 8 plus 3. AM3 is A1 plus 3D. That means 3 plus 3 times 4. 12 plus 3, 15. Now you can check this. 3, 3, 7, 11, 15, 19. This is the sequence. These are the three arithmetic means that you have inserted. You can check 3 plus 4, 7, 7 plus 4, 11, 11 plus 4, 15, 15 plus 4, 19. This is an AP, right? So this is the way we insert arithmetic means. Now, let us do what are geometric means. Geometric mean. Geometric mean means, now go by the concept. Like when we talk about a single mean, we have two numbers, A and B. We have to insert a number C. Now, what is the concept of geometric mean? Geometric mean, that means when we multiply a number by a particular constant, we get the second number. We multiply this by the same constant, we get this number. That means C divided by A times something, na? So C divided by A will be equal to B divided by C. Like the gap between C and A, right, is the same as the ratio between C and A is the same as the ratio between B and C. Geometric mean, geometric progression works on common ratio. Arithmetic progression works on common difference. So the common ratio is the ratio between this and this number, C and A, is equal to the ratio between B and C. So we get C square is equal to A into B. Remember this formula. In AP, in AMs, we have 2B is equal to 2C is equal to A plus B. Here C square is AB. So what does the geometric mean? C. These formulae you will be remembering. Geometric mean between two numbers is square root the product of those two numbers. Geometric mean C between two numbers A and B is square root of the product of those two numbers. Right? So this was the case when we had only two numbers. Now if we have to insert more numbers between two numbers, like if we have A and B, and we have to insert, let's say, three numbers, right, between A and B, so that the resulting sequence is a geometric progression, right? For that, what do we need to do is find the common ratio. The common ratio for this becomes this whole ratio between A and B. The whole ratio between A and B is divided into the intervals raised to the power 1 upon n plus 1. Right? So if we are inserting three numbers, this whole ratio will be divided into 1 by 4. Right? So let us do one example. If we have insert 5 geometric means between 576 and 9. 576 and 9. Right? These are the two numbers. This is A and this is B. Insert 5 geometric means. So n is what? N is 5. Right? That means, first of all, you have to find the common ratio. What should be that particular constant which should be multiplied to this to get the next one, to get the next one, and so on. Now R is B by A. B by A divided by 1 upon n plus 1. Right? That means, what is B here? 9 upon 576 divided by n is 5. 5 plus 1 is 6. Right? Now what do we get here? This is 9 times 9, 6 are 54. 9 6 are 54, 36, 9 4s are 36. Right? How do we solve this further? This is 1 by 64. That means you can write this as 1 by 2 raised to the power 6. 64 is nothing but 2 to the power 6. Raised to the power 1 by 6. Right? So we solve this and R comes out to be half. Right? So this is the value of R. 576. 1, 2, 3, 4, 5, and finally we have 9. Right? So start doing this now. What is AM? Now you have to treat this as a GP. You have to multiply these numbers by 1 by 2 to get the next term of this geometric progression. GP works this way, right? So the first GM, GM1 is, if this is A, this will be A times R. 576 multiplied by half. 2 2s are 4, 2 8s are 16, 2 8s are 16. GM2, you have got 288 now, right? 288. Now this gets multiplied by 288 multiplied by half. 144. Right? GM2 is 144. GM3 is 144 into half. That is 72. GM4, 1, 2, 3. GM4 is 72 times half. is 36, right? And GM5 is 36 times half, that is 18. And 18 times half will be 9, right? So this way you have inserted 5 numbers. You can see that they are at the constant gap in terms of multiplication. Every number is half of the previous one. Half of 576 is 288, half of this is this. And this way we get this as a geometric progression. And the numbers inserted between these two numbers are called geometric means. So this way you have to find the value of r first, and then you can keep multiplying the value of r to the existing term to get the next term. So I hope the concept is clear between AM and GM. If you have any doubt or you like watching this video, you want to take classes, please contact me through our info. Thank you.